So Dan Janzen, and you're with you're in the Fellowship of Christian Farmers seminar room, and we're very happy to have you here today to join with us. This is issue of um, of demonizing CO2 um, is something that I believe we need to push back against because God put the different gases in the atmosphere to be a blessing to us. And CO2 is basically an elixir to life. With we were so far down on CO2 during the ice age, and even the little ice age, that we were getting close to the level at which plants couldn't even hardly survive or be very productive. And so we're going to push back today against this idea that we need to be alarmed about CO2 increases. So that's what my title is today, How Rising CO2 Levels Supports Global Agriculture. It's a net benefit. Yes, we're going to get a slight bit of heating because it's a greenhouse gas, but that slight bit of heating we'll discover is not very significant in any negative way. So what's the factual analysis here? Um, let's look at something called leaf area index. Now, leaf area index sounds kind of complicated, scientific, kind of thing, but it's really only what's the surface area of a leaf. And when we look at the total surface area of a leaf, um, is that increasing or decreasing? We'll be very surprised with what we find when we look at the satellites, what the satellites are showing. Now, this is the whole globe, and we've done something to the globe. We've actually added colors, the green color to show where the leaf area index, or the whole surface of leaves, is increasing. We've represented that in green. Now, does this map look brown like it's decreasing, or does it look green like it's increasing? Increasing almost everywhere. So much so that only 4% of the earth is actually turning a little bit, losing leaf area index or turning browner. Somewhere between 40 and 80% of the earth is greening, depending on how you consider significant increase. So anyway, this amount of additional greening is so significant that you could put 2 layers of leaves across the whole United States as a representation of the amount of increase in leaf area that's happened in the last 35 years. And this is with satellite studies. The satellites don't lie to us. They can help us push back against this extreme alarmism. Okay, so we could put a layer of leaves across the whole Amazon water basin with the amount of additional leaves that are out there that weren't there 35 years ago. Okay, well, they say, okay, yeah, but you don't really have me convinced. Let's just go out to the landscape and look. Now, if you look at 1925, this is a landscape in southern Africa savanna, and CO2 does a lot of help to things in drier environments. That's where it really excels in its ability to help when we have increases. 2011, it's the same landscape, but what's the difference? It's greener. It's got a lot more trees too. Okay. This is a representation of what's happening all over the world. This is what we saw on that global map. This is what it looks like when we actually go out and actually see the difference. A great example. Here's another place, Cape Providence. Um, and this came from one article. You could go and research this and find it all over the world. 1954, 2010. This is not management practices difference. This is CO2 difference. Okay, 1945. This is what the landscape looks like, and we go to um, to 2018. 1945, 2018. Big difference. All over the world we find this. So, so CO2 acts like a fertilizer. Um, the optimum, and this is just in a conservative study, the optimum level of what we discovered in the lab is about 1,200 parts per million. But every doubling of CO2 generally produces a 33% increase in production. That's very significant. This is the pushback against alarmism. Here it is. You can see it, what happens in the greenhouse. This study was done when the ambient air was 385. This is 535. We're actually somewhere between it, around 460 now. Okay, that's 150 parts per million increase. This is 300 parts per million increase, and this is 450. We're going to say what? It looks like about double the height at least. Okay. Now, this is not the whole story of the. This is actually biased. This is a pot in a greenhouse, and we're going to find out a reason why this actually what we expect is going to be much greater from the yield increase, and it's something we're going to look at here in a moment. So we'll come back to this. Um, so what's happening that's in science that's making CO2 increases so much helpful to the plant? Well, the stomata, those little gas things that are in the plant, they've actually gone back in herbariums to the 1800s, and they've looked at the leaves and they've go, oh, wow, there's less stomata. I mean, there's more stomata in the leaves than there are now because the plants are adapting. They're not putting as many stomata. They don't need as many stomata, those gas exchanges, and it's less efficient to put those in. So they're conserving their own materials by not putting as many stomata in the plant. The stomata don't open as far and they don't have to open as long because every molecule of CO2 that's taken in, the plant will lose 100 to 200 parts per million of water or water vapor as it opens up. So if it doesn't have it open up as long, it doesn't lose as much water, more water stays in the ground, and that water can be taken up. Now, if you have no-till farming and you have this nice coverage and you're mulching, you're just synergistically enhancing the effect of conserving moisture in the ground. What CO2 is helping, the no-till is helping. Photosynthesis is improved. There's signaling pathways, hormones in the plant. We're going to get into the rhizosphere, or mycorrhizae, and the bacteria and exudate. Exudates. A plant that's healthier if it can produce a huge amount of exudates, connecting to the rise, it's going to have a very enhanced, increased amount to produce. So it exponentially builds on itself when your plant is feeding the bacteria and the mycorrhizae more exudates, sugars. So there's a synergistic benefit there. So then so all of these substances being taken up because there's a bigger mycorrhizal mat, because of the exudates that are going out from the plant, more of them is going to make a big difference. So we're going to get into how does it affect the optimal temperature for photosynthesis. And we're going to look at some of these other things, but not in so much detail. There's a lot of things we just can't cover. We don't have time. So Um, so when we look at CO2 in a cornfield, and we've done the studies of the canopy. Okay, so what happens in the middle of the day when the plants are the corn is growing like crazy, it can deplete up to 75% of the CO2 in that canopy. Okay, therefore, here's another reason why the level of CO2 in the atmosphere is not a good reflection on the actual limits to agriculture, because if you have a depletion in the cornfield, you need much higher than 1,200 parts per million to keep that corn from restore that and hold that back, that 75% depletion. You need to hold that back and have much more CO2 out there when the corn is growing actively. Otherwise, you're putting that corn at near starvation because of the competition between plants. Okay, so we've seen results up to 2,400 parts per million of being in the plant is still growing and increasing its yield even at that level. Okay, you go back in historical time frame, you find levels up to 3,000. If you're in a submarine, they don't worry until you get up to about 10,000 parts per million. But they'll exchange that, and they have systems in the submarine to absorb the carbon dioxide that's happening there. Um, so um, we can see these CO2 when it's increased its level in the atmosphere, we can get optimal um, photosynthesis temperatures increasing to 95 to 100 degrees. Now, that's why in an arid environment, CO2 increase is so significant. Because, or we were going into a droughty conditions when you're farming. When we're all rain fed. You guys are all rain fed. Most of you. That's where CO2 really excels in a rain-fed environment. Not so much in an irrigated environment, but in a rain-fed environment, it excels. So let's look at this mycorrhizal, what's happening there. Now, particularly since we've been doing no-till farming, we're not disturbing the soil. These rhizal mats can head out and connect up to, they've even measured them out to a mile out there. Okay, so imagine what's happening in the you can actually I should show you the video they put some kind of um, radioactive material in there to show it can track the movement. But these things are just moving like crazy back and forth in these mycorrhizal mats. The exudates are going out to feed from the plant, and then the nutrients are coming the other direction, and it's amazing what's happening. It's just like a huge extended root system. Do you think we'd see that in the lab when we have pots? No. When in a greenhouse, when we just put a plant in pots? No. When we have the increased photosynthesis and the exudates going on with the plant being a whole lot more healthy, we've got mycorrhizae that's a whole lot more active because it's being fed extra amounts of exudates. The bacteria also in the soil, they're moving things back and forth, back and forth, back and forth, and the plant's feeding them. And a lot of this has just been discovered relatively recently, particularly in the area of bacteria that move different elements back and forth. And the plant just basically tells it what it wants, kind of. Somehow there's a chemical signature. The plant tells it what it wants. It goes out and finds it and feeds it, and then the plant feeds it more exudates and rewards it. It's a synergistic thing. So if we're going to terraform a planet, what do we want? We want more warmth at night, right? I mean, talking about terraforming, meaning we're gonna like if we were imagining we're the creators of a new planet, and so we're gonna have a greenhouse effect, right? We're gonna have with the greenhouse effect, we want to enhance that um, stabilization from oceans, huge oceans that can moderate the temperature up to 500 years, so that if you get more active sun or less active sun, that's all moderated. Okay, that's what we have. We have we have this greenhouse effect, and the more greenhouse effect we have, the warmer it stays at night. And when do your frosts happen? At night. That's what shortens the season. You get a frost at night. So if it's warmer at night, that's a good thing. And you can farm further north as a result, because a lot of our land base is to the north. And use a longer growing corn. This is what we're doing now. We're using longer day corn and further north. That's a good thing, and it's more because it's more productive. And then we in the wintertime, it's not as cold when you have a stronger greenhouse effect. That's why we have greenhouses. We go and we plant things in the greenhouse. Us farmers, we know about these things. We don't understand these alarmists and what they're all excited about. It doesn't make any sense. You want to terraform a planet, you're going to choose to have an enhanced greenhouse effect. And so we're gonna look at some things that happened in the. Go ahead.
I kind of disagree with you. Most farmers don't know this.
Oh, okay. We need to
Talk to them.
educate them.
Huh?
We need to educate them.
No, talk to them. They don't know about it.
Yeah, that's good. I appreciate that. Yeah, that's why I'm here. And if you have a question or anything, feel free to ask questions. This needs to be high. This should be interactive. If you don't understand something, or maybe I'm not explaining it well. So, um,
I got a question.
sure.
One of the universities, they did some trials and
Hmm.
they added some carbon dioxide or dry ice out the cornfield.
Yes.
Bumped their yield way up,
Yes.
but it's not economical to do it.
No. No. But we might be able to look at that and figure something out. Some of our young people, are we directing our young people to excel um, in these types of sciences so they can find those kinds of solutions? We need to. We need to and encourage them. And our investment in our young people, they're the ones that are going to be purveyors of new technologies and help solve problems. Just like the early reformers, when they realized that they better be applying godly principles, that God's an orderly God and he designed laws to be discovered. And so you have Isaac Newton and Boyle and Pascal and all these early scientists, the Puritan Scientific Society that happened. Um, those were researching things, finding solutions because they're driven by godly principles to maximize the blessing. It's like God called Abraham to be a blessing to the world, and he blessed them to be a blessing. We're blessed to be a blessing. How can we maximize our blessing as farmers to the world? This is the question. And we can bless people with truth, and then acting on that truth, and out of our prosperity, giving more and spending more time helping people less fortunate than us. Global carbon uptake doubled in the past half century. Okay. So they're trying to do these calculations out there and they're trying to figure out, why don't we have more carbon dioxide in the atmosphere? I mean, where's it going? Something's wrong here. It should be building up and should be increasing. Well, half of the carbon dioxide, even coming from man's use and production of fossil fuels and things like that, cement making and things like that, it's actually going into the plants. That huge amount of increased leaf area index is where that carbon dioxide is actually going. Okay, so it's taking up more carbon dioxide, which is good. Geologically speaking, we're in a huge slump in terms of carbon dioxide level. When we measure the past, we found levels 3,000 or even more. I think there's estimates that it depends on the scientist. 5,000-6,000 parts per million in the past. What did you see in the fossil record? These huge, massive amount of vegetation, club moss. Well, club moss doesn't grow like that anymore today. It's like growing to the ceiling or whatever. And then we have a fossilized. We have a record of how much vegetation there used to be in the past, and things used to be massive. And all that massiveness, what did it do? It got covered up in a global flood, and it got a huge amount of pressure put on it, and where the sedimentary rock was permeable, it became coal, and where it was impermeable, it became oil and natural gas. And we benefit from it today, and we should be using more of it to maximize the blessing from those things. Um, CO2 increases historically lag behind temperature. We've looked at the buildup of temperature and we correlate it with the buildup of CO2. The CO2 is coming increases are coming first. Okay, so they're leading and they're building up first, and then the temperature follows. That's what we see in the last couple hundred years as the temperatures have been increasing. The the um the temperature increase comes first in the CO2. Why? the ocean is a huge repository of CO2. As the ocean is cooler, it stores more CO2. As it gets warmer, it releases it. We actually like to see it released, not held in the ocean. It benefits the plants and it benefits our greenhouse effect. So CO2 increases the fingerprint in terms of warming the troposphere, which is the area right around the Earth. It's very insignificant. We don't even hardly see it. The increase in CO2 is not having much of an increase. The predictions that are happening by most scientists are over predicting the amount of increase of temperature. So I don't think it's something we need to worry about too much. The increase in temperatures actually so far been very positive. CO2 influence on temperature is logarithmic. It's a diminishing curve. Okay, so these are some of the predictions of what's going to happen with the temperature based on various predictions. It's really hard to predict. It's not an exact science. So these are pretty flat curves because in their diminishing curves, they're going like this. Okay, so um, if you look here, we will see that the temperature impacts. Um, I'm looking for my pointer here in my pocket. I do with it. Put it down. Um, oh, I found it. Oop, that's not it. I do have a pointer that would be helpful in this situation. Oh, I found it. We'll cut that part of the video out. So anyway, look here, all these different increases in parts per million of CO2 in this area right here. Okay. Now here is how much temperature influence is remaining for all of these different levels of increase here. Okay. It's not much. It's about 13% of the potential influence of increasing CO2 levels on temperature. And only about 13% more remains to influence the atmosphere. It's a diminishing curve. And so here you see it in a different way. If you look here now at 20, 60, 80, 100, there's the region of parts per million of CO2, which is most influential on temperature. The rest of this, anything above that, has almost no impact on global temperature at all. Almost nothing. So as we are up in this area, right up in here, okay, we're up in this area right up in here right now. We don't have much influence left. We don't have to worry about this. It does not going to have an impact hardly at all. So the main impact, we'd have to take it down the CO2 level down to this area, which is plant starvation area. Um, plants growth shuts down here at 150 right here. We'd have to take it back to this level to have very much significant impact on temperature at all, and that'd be terrible because we'd lose our greenhouse effect. So notice here, most plants, like cereals, C3 cereals, um, uh, where we're having a 49% increase in growth, legumes, roots and tubers, vegetables, 37. These ones here, there's a huge increase in production as a result of higher CO2 levels. Um, so if this is just adding the amount of percent. Um, let's see here. For 300 parts per million increase in the atmospheric CO2, you get this increase in production. That's a lot. Okay, so that's not even a doubling. There's a few plants like succulents and cactus that have a low amount of increase because they're already very efficient in dry areas because of their type of photosynthesis. It's cam type. Anyway, let's look at the little ice age. So the little ice age, there was less sunspots. Okay. And there was increased volcanic activity. That had a huge, huge influence. If you want to influence the weather, volcanoes will do it for you, and to the point where people won't even have a summer in certain parts of Europe. They don't even they everything is frost all summer long. That happened for 2 years in a row after a volcano one time, and you have um, as many as 50 million people can die as a result of having not a summer all around the world. Starvation, yeah, 2 years in a row. Um, the production rate fell by half in Europe, in other places. Um, Widespread famine and cannibalism. Um, Cultivator land shrunk. We have historical records of of glaciers coming down into Switzerland and just wiping out whole villages, completely gone, wiped out in this time frame. Um, Witches were blamed for climate change. Now, this is something interesting you don't find much in the literature, but in the late 1300s, 1400s, is everything okay on that? Oh, okay. So 13, 1400s, uh, they were blaming witches, innocent older women maybe, um, for changing the climate and creating these frosts. And there's historical evidence that this was happening, and hundreds of people, particularly women, were killed and because of blaming climate change on them. So even if you go to China, the unusually cold, dry weather, it can uh, um, cause less rainfall to happen, and you have a drought, and you have these huge famines that happened in China during the Little Ice Age. So we're not talking about temperate zones; we're talking about tropical zones too. Um, but the medieval warming period, let's look at that. This was a warm time frame. Population of Europe doubled, and the medieval warm period came before the Little Ice Age. Few um, and and poor harvests, famines infrequent. Grain was grown in Iceland and Greenland. Today, do we grow grain in Greenland? No. No. We're just starting maybe a little bit in Iceland to grow something like barley or something like that. Northern fisheries flourished. And so, and even the fisheries were further north, like the what is it, the banks of off the coast of Nova Scotia. Those were shifted north for northern fisheries, and vineyards 500 kilometers north of where they are today, and 200 meters higher extended. And permafrost. Um, I found an image of a Viking body they exhumed from or dug up archaeologically from a from permafrost in Greenland. Okay, what was inside growing through the body? Tree roots. It's permafrost today. Tree roots back then. What does that tell you? It was warmer. It was warmer back then. When you talk to these biased alarmists, they don't want. In fact, there's even something called climate gate, and they were actually trying to represent the data so that they would exit out. It would eliminate. Get this hockey stick type thing, and they're actually talking about how they were going to do this, and it came out in a leaked out that they were trying to eliminate the warming period of the medieval warming period. They didn't want it there. They didn't want to acknowledge it. It messes up their alarmism. Retreating glaciers revealing tree stumps. You have tree stumps where glaciers are today. Excuse me, but that's like what? Well, a lot warmer in the past. Okay, and this is not just an isolated incident. This is common. Tree line located at least 100 to 140 meters higher, meter like a yard, we have other evidences. If you look at tree rings, and during the medieval warm period, they're really wide and they were really growing, and so they would you base it on that, which is real data, not just guesswork. This is what you see in the past, these kinds of patterns. Okay, and this is from proxy data gathering. Here's oxygen isotope from the Greenland ice cores. This is tree rings in China. This one is uh, from the northern hemisphere, like different tree species basically averaged out. Well, that's what you get. And you have this really high point in the past around 1000, 1100 AD, 900 AD, and it's warm. And there were other warming periods in the past. There's the Miocene and the Holocene and um, or different periods of time when it was really warm in the past. And the Roman warming period too. It's right there on that. Okay, so what are the top ranking environmental hazards? What should we really be concerned about? If we're strong Christians and we need to have an impact on the world, what should we be concerned about rather than the climate alarmism? Indoor pollution, cooking, heating, it kills 4 million people per year, respiratory infections. You know, you're in a hut and you're trying to heat your home or cook with on open fire in your home, and you have smoke all around you. You're carrying your child on your back. You're a woman, and you're now going to have cancer rates that are high, respiratory infections, eye infections and problems, and heart disease and strokes. All these things are killers because you're breathing toxic chemicals in the air. Contaminated water, inadequate sanitation. These are problems that can be solved, okay? Instead of spending trillions of dollars on climate change, and which is wasted. And we had someone talking about was it you that was talking about piping CO2 and putting it into the ground? That's stupid. That's a complete waste. Even the subsidization of all these things is a waste in almost all cases. 1.6 million children die from contaminated water and inadequate sanitation. It's very sad. Oh, malaria, mosquitoes. It's a solvable problem. 1 million dying per year, maybe more, maybe up to 2 million. It's hard to tell you. Go to China. Here is a huge problem. Probably one of the biggest environmental disasters in the world is the extraction of rare earth metals. Okay, what they do in China, because the government really doesn't care about environmental destruction, they just want money to be made, is they gather up all this earth material that maybe have a slight bit more composition of these rare earth metals, and then they put this acid in there and it etches out all of these um, all these rare earth metals, and so they extract them. But what do they do with all that acid and contaminated stuff? They just leave it in these tailing ponds. And anybody, if the tailing pond gets a bunch of rain, it overflows and goes down into the watershed. That's that's horrific environmental hazard. Anybody who lives with near these things, they get cancer rates are very high, hair fall out, teeth fall out. I mean, every kind of problem, lung problems, everything is going on. You you want to talk about a huge environmental hazard? That's the tailing ponds from the rare earth. Where do we use those rare earth elements? Any idea? Batteries? Yes. And and we also use them in solar panels, and we use a bunch of them in making lightweight turbines for wind farms, electronics and things like that. So um, if we're using a high percentage of them for trying to eliminate a supposed environmental hazard and creating a much bigger environmental hazard, it doesn't make any sense at all. And and, and so it's just getting really ridiculous. So what happens now with when we look at things like wheat production in India, or and what are the doomsdayers saying? Oh, the earth is coming to an end, Chicken Little kind of thing. The sky is falling. Okay, but no, it continues to go up in India. And one of the reasons why we have low commodity prices today is because the rest of the world is producing pretty well, and farming is increasing. So, and 15% of the increase in yield is coming from CO2. But then there's also the better varieties, the fertilizers. It all comes together. But we need to give some due to the CO2 where it belongs. So, increase, and there's increases in all areas. Everything is expanding. That's good. Why do we need to push these environmental policies like Sri Lanka? Sri Lanka decided no more pesticides, no more synthetic fertilizers. That government disappeared within 6 to 9 months. That guy was thrown out, and they invaded his home area, and he had to flee the country because he brought so much economic devastation and starvation to the country just from pushing that direction. And the Chipko movement in India was a disaster. Anytime we let the environmentalists, alarmists, um, push extreme policies, some policies are good, and we agree to them. They're part of the stewardship mandate. But many of them are just plain evil, and cause us to move in the direction of increasing hunger and starvation, deprivation. So the cost of curbing CO2, Born Larmberg, a Danish statistician, says we will spend at least $100 trillion in order to reduce the temperature by the end of the century by a grand total of 0.3 of 1 degree, the equivalent of postponing warming by less than 4 years. Al Gore agrees. He had an interview. Chris Wallace had an interview with Al Gore, and Al Gore basically admitted we're not going to make much of a difference. And his idea didn't even make sense that we'd have a signal. Um, can we? Why the signal? Um, well, it really doesn't make sense. It just wants to send a signal that we're trying to do something, and we're not doing anything. So it's incomprehensible, really. He Al Gore just doesn't make any sense. Any of his policies.
What's their objective? To control society and make utopia? Or is it to
Well, there's more than one objective. Some people are benefiting, the elitists, sometimes they benefit from regulations. If you're in an international elitist, you love change. Okay? You love regulations. Regulations produce change. What do you do with your portfolio? You rapidly move it. You have the flexibility and the ability to do that, and you capitalize on whatever's happening. Okay, so that's a benefit there. They love those kind of regulations to go in effect because they can move their portfolios in advance of everybody else, and they can benefit. Okay, so then you have other people that are messed up in their thinking. They're not thinking Christian worldview and maximizing the blessings of the world. They're thinking something like um, man must be at the bottom of the food chain kind of thing, and subservient to all the other creatures, because all the other creatures must proliferate, and we must reduce our impact because we're blighters and polluters, and nature is some kind of delicate balance by millions and millions of years of evolution, and it's created this delicate balance. We do one little lift, one finger of impact, and we're going to make a massive trickle down, or positive feedback. They call us a positive feedback thing because we don't see the environment as resilient and stabilizing. They see it as something that that any kind of positive feedback will just run away and create huge problems for us. And so they're always in this mode of alarmism, and it's been that way for a long time. First it was ice ages are coming, and then now it's global warming, but the global warming wasn't really seen, so they said climate change. It's the extremes now, and whatever, and some of it's been good, to we've cleaned things up. Lake Erie used to burn on fire. That was bad. That was bad stewardship. But appropriate approaches are um, uh, constrained by Christian worldview or promoted through Christian worldview are really what we're going after when we do that. So best resources, I've listed a few there, and I really like the book Fossil Future, why we need why global human flourishing requires more oil, coal, and natural gas, and not less, and Cornwall Alliance. And also, I want to conclude here that with this message, that free markets and human ingenuity in the context of advocacy for policies that prioritize human flourishing have potential to alleviate scarcity. Okay? You need a strong, mutually beneficial exchange of goods and services happening in society. You need Christian worldview where people put other people first, and prioritize toward serving others and taking their prosperity that we get and and allocating some of their time and some of their money toward strategically working with those that have less than us, asking questions like, let me into your life and see what's holding you back from your full potential. So um, we are we are in this mode where we are called to be a blessing to the world, and if we hold that blessing back and we absorb it in leisure and luxury and consumerism, um, some consumerism is very appropriate because God's called us to 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 uh, enjoy some of the things of life. He says He's given us everything for our enjoyment. Okay, that's a verse in the Bible. But when we fail to address the issues in society, what's causing oppression in terms of lack of freedom and in policies and in environment and freedom and lack of, and not address poverty, then out of our prosperity, then that's not good. And sometimes right now we're in a mode of look what we've done instead of look what God's done through us. Those are two distinct ways of looking at things. And we tend, when we say look what we've done, we tend to want to consume our with leisure what we've done instead of how can we help others now with out of our prosperity. There's a two different pathways. One is a great commissional pathway. The other one is a pathway of a retrobate person, basically. So
Okay,
yeah,
all figured out. We can solve the world problem.
we can solve the world's problems. Sure, we can, but we're not going to solve everything. Even Jesus said, "The poor you'll have with you always." But it's still the responsibility is still there to and we might think something like that when we have a spiritual situation of working with people's souls instead of a Mother Teresa approach, which never ever impacted a person's relationship with God in terms of sharing um, sharing the gospel. She didn't share the gospel, she just helped people. We need both. We've got to have both. We're concerned about their eternal destiny, and we're concerned, and that relationship with God transforms their lives, and they start to live differently as a result. Okay? So, missionary movement was a phenomenal movement, and it's transformed the world. Read about what happened to India as a result of what William Carey did there. It was phenomenal.
I got a question.
Go ahead.
You start out, you know, like the lead cover.
Mhm.
You ain't fixing the ladies.
No, not. I mean, well, we can find them, but
I mean, that increase down there.
um,
They say that the problem in there is everybody's cutting down the trees for charcoal because they're poor. And then everything's eroded and there's nothing growing there.
if you fly over the top of Haiti into Dominican Republic, there's a world of difference, night and day difference. My parents have been to Haiti, and they don't have good agricultural practices. They just denude the land, and these hillsides just wash away, and they lose their topsoil. It's We know how to farm appropriately, but but people that don't have that worldview um, necessary for understanding and experimenting and finding the best solutions, um, they're going to ruin their opportunities for the future through erosion and things of that nature. So in Dominican Republic, they have a program where they try to reduce the amount of cutting of trees by they're subsidizing fossil fuels in Dominican Republic. That helps a little bit. I don't know if it's the best approach because I like market approaches better, but um, if people put a wood lot in and increase their production or grow them in places, Haiti could be growing wood and wood lots um, in places. That's God sending us a message.
Yeah. Question about Brazil, you know, they're
Yeah.
cutting down a lot of forest. So is that why that area is kind of more brown instead of
Could be. Well, there's parts of Brazil that are drier too. So if you cut the trees down,
they're deforesting a lot of the forest there to increase their agriculture.
yeah, you'll notice that that happens in areas where the people are poor or where they don't have good policy in place for managing. When we have Christian principles in managing for the future and productivity, we don't do that. Okay, but when people are wondering where the next meal is coming from and they have international companies that don't pay much attention to good policies, then they can do that without replanting. But here, where there's good policies in place, like we have on my parents, my grandmother's property, we've harvested the Douglas fir trees 3 times. We replant, and the law even tells us you have to replant. So we replant, we harvest, we replant, and it's productive. In fact, the conservation movement was a good movement originally, until the preservation movement and then the extreme environmental movement came along. But the conservation movement was all about how do we um, conserve what we the opportunities that we have now into the future, okay, and steward our environment well. And so and so when you have a conservation movement that has that kind of focus in carrying the opportunities and the prosperity from those opportunities into the future and giving it a good inheritance, that's a good thing. Okay, but we've lost that and we've now gone on a non-impact, non-touch kind of thing. And so in Brazil, um, uh, um, and there's other things too that's happening in Brazil. Like sometimes they'll clear some land and they'll put it into agriculture. Agriculture also sequesters a lot of CO2 and is very productive. So and grasslands are very productive if you convert from tree cover to grasslands like they do in some places. They're not. It's not an environmental disaster to do something like that because um, grasslands that are very productive. So yeah.
What you've been saying here, I cited some data that said that in Brazil, if it was scrubby ground that just had kind of rough growth on it, and you put crops on it, you actually had a better environment.
Mhm.
In the Amazon area where there's you see some of that. Negative thing.
Right.
Things I saw many years ago, I saw the border of Haiti and Dominican Republic, and you can see the border right down there because in Haiti, they had stripped the place and was eroding.
Mhm.
Looked terrible. And you can see right down there, okay, this is Dominican Republic, they're not allowed to go over there, and they had green road.
No, that's exactly confirming what I was saying. You fly over an airplane, you see the massive difference. My parents were there. My dad actually was helping build roads with the Caterpillar in Haiti years ago.
Here's another observation. You get a form field and you get your tillage and biology going. You look at it, get a tape measure out, 8 by 4 inch wide corn plant, but you get really good corn growing and be 5 inches wide.
Mhm.
That gives you 20% more
Mhm.
sunlight capture, more biological
Mhm.
factory,
Mhm.
bring more corn.
Mhm.
But you got more leaf bearing.
Mhm. Mhm.
But what the secret is, that most people don't even know, 95% of your nutrients come in the air.
Mhm.
So you got all these people out here selling fertilizer. It's a catalyst, works, it may or may not work. And all these farmers think we got a chemical system out here.
Mhm.
We got a chemical factory, it's all biological.
Mhm.
And the more biology you get, the better that creates gas exchange in the soil.
Mhm.
And raises up your carbon level.
Mhm.
You got good biology. You can go at 400, 600 or 800. Good biology. And so that's the secret. Make the deal. And it's like you said, we have not even begun to capture how much we could grow.
That's right. And
There's people out there doing 600 now
Mhm.
with various things,
Mhm.
and you know,
Yeah, there's all kinds of good technologies out there that use biological systems and enhance those biological systems that God gave us. And when we learn more and more about how exchanges happen between the exudates and the plants and even there was something I was learning about how trees go down deep into the ground and hydrologically pump water up. They release it near the surface and then pump it back in so they can get the nutrients from the surface. That's amazing. Who would ever thought that a system like that would be out there? And all the other plants around it on the surface that are on those trees, they benefit from. That's why you go some of these drier environments, things underneath the trees, they get a little bit of shade. They get organic matter falling down from the trees, and they get that hydrologic pumping, all kinds of things. So trees can be a nurse to crops. That's why we developed the system of agroforestry. And I promote a lot of agroforestry principles overseas. But once we get irrigation, some of those agroforestry principles aren't necessarily worth the amount of labor that they take, and so the benefit. So we need to be evaluating the still doing experiments on all these different things to see what our costs are and what our benefits are, and cost benefit analysis or income per hour or return on investment analysis. Those are the kind of things that need to be taught overseas, and they need to be able to develop that enterprise accounting. Those things. And they don't have an excellence standard generally overseas, and we have a higher excellence standard. We can teach those types of things, and they might teach us some things too, that we can learn hospitality from them. They're much more hospitable as a people overseas, and the friendships are much stronger. We can learn a lot from them too.
but one thing I might mention too, whenever you see a product, pesticide, whenever you put it in the side, that means a kill. You spray something, any side you want to call it, you're destroying life without,
Mm-hmm.
so that's what I'm organic.
Mm-hmm. Mm-hmm.
If you call it organic, they don't like chemicals,
Mm-hmm.
because we're destroying the biology. So the whole chemical system is a man-made thing. The whole organic growing thing is that was God creation.
Mhm.
And so most of the people that are organic are Christian,
Mhm.
and I mean, mindset.
Mhm.
That's all.
Mhm.
And so I think you follow organic.
That'll be tomorrow. We're talking about that tomorrow and on Saturday. We're covering a lot of ground on that. How do we evaluate things on the basis? And I would recommend reading um, a gentleman named Dr. Bruce Ames, and he tested 52 naturally occurring chemicals in plants, and he found that of those 52, half of them had mutagency potential to cause cancer, things that are actually in plants. So I think I think we're completely off in our thinking if we don't evaluate every single natural and synthetic chemical in terms of its cost, I mean, in terms of its benefit and risk propensity. We have to evaluate them individually. This whole grouping of things, organic and synthetic, into organic and synthetic categories is really unproductive way of viewing things. Everything must be evaluated on the basis because God, He gave us everything. And when God made Adam, He used chemistry. He took the elements of the earth. He set an example for us. And when he made Eve, he used biochemistry, and he made it out of a rib. So he gave us both systems, and we need to use both systems to maximally bless the earth. So just like a weed is a flower out of place, a noxious chemical is a chemical out of place. It's There are good uses and bad uses. I can't think of any single chemical that doesn't have a positive use to it. To it, it depends on where you put it and the dose makes the poison. So in that context, I think we need to evaluate things with wisdom, um, every single thing on an individual basis and where we put it, and the dose makes the poison. Um, because digitalis, what does it come from? It's a heart medicine. It comes from a very poisonous plant that if you eat that plant, you're dead, but we can extract a small amount of that and stimulate the heart at the right level. And so almost everything natural and chemical and synthetic, it has its potential way to maximize the blessing to the world. That's my viewpoint. And I don't like people grouping things. Personally, I don't like people grouping things into organic, synthetic controversies, because that's not, in my opinion, that's not a Christian way of looking at things, to group them. Um, they need everything needs to be evaluated. Hemlock is and snake venom are very toxic. Okay, can we get something from them sometimes for medical purposes? It's possible, you know. So everything might have a potential benefit, but we have to be very careful and do our analysis properly and use the scientific method. I think we moved away from the scientific method, and we're pursuing ideologies now, and these ideologies aren't maximizing the blessing. If to label something as bad if it's synthetic or good if it's organic doesn't really fit. In fact, the organic producers now, they have their own rules that keep them from being organic. You can't use rotenone. You can't use tobacco. Well, they're just going back to the what's obvious when they say that is that every single chemical needs to be evaluated individually. Don't group things together as bad and good because they're organic or synthetic. It's bad. If you take an insect growth regulators, I'll challenge an organic person that if you're using insect growth regulators, you're using a safer form, and there's a synthetically generated, you're using a safer form of control mechanism than the organic people can come up with. It's automatic. If you use an insect growth regulator, it's going to be the most safe because it doesn't affect mammalian populations. It controls the um, chitin development and an arthropod an exoskeleton, doesn't target a mammal. So if people use a synthetic insect growth regulator, that is a non-organic approach, but that's actually the safest approach. So don't mix these whole things up together and try to make them into safe and non-safe. I don't think it's wise. I don't think it's even a Christian thing to do.
Why don't we look at, okay, what's the cause of whatever, insects and stuff?
Mm-hmm.
We always want to get rid of the insects, but what's the root cause of it? That's the way I take my farming.
Mm-hmm. Mm-hmm.
Just because I got aphids out there on my soybeans, what caused the aphids to eat my plants anyway? Because my plant is not healthy.
Well, and therein, when we go to these organic people that are trying to grow all organic, and we're looking at the cause, they oftentimes excel at that area. So we've got a lot to learn from them because they're trying to do something that is all organic. So I love to learn from the organic people because they might be more prone to look at the cause and have a better idea of what the cause is, because if we can control with pesticides and we're missing that cause side of it, and we're missing control measures that could be used instead of that are and are more cost effective, particularly in the area of cost effective, then we're missing out. And we can learn a lot from the organic people. So therein is where the organic people oftentimes excel, because they are trying to do something with a more limited tool basket. And because of doing that, sometimes they come up with things that are better than the other method, even in cost.
Yeah, we gotta look at both.
Exactly. So we got a lot to learn from one another. We really do. And so that's where I really appreciate the organic people, because their constraints cause them to find solutions that we might not even think of. Yeah. Yeah.
One thing, you were saying about mankind, and I guess one, reading, but then, life suddenly came on, that there are two categories out there.
Mm-hmm.
It's you're worshiping God or you're worshiping man.
Mm-hmm.
So it's all money. So watch your motives.
Mhm.
Why are we doing what we do? Because to make money and we're worshiping money, or do we want to help mankind and do God's will or do God's way and do His thing? Is that why we do things?
Well, that's a little bit of a confusing thing.
So that, everybody, our whole life kind of reveals around money. We're off every day.
Would we do, the question really in my mind becomes, would we do something that is oppressive to others because of our seeking greedy, which we call greedy, in a pursuit of or jeopardizing the what we're going to hand off to the next generation in as inheritance? That kind of constraint is a good constraint. But just saying we don't want to necessarily make more money, um, I when I'm farming, I try to maximize the amount of money, but I'm also thinking about relationships with, relationships in terms of what I'm going to hand off to the future. And I'm also thinking about the amount of time that I'm going to be able to spend with other people while I'm farming, impacting their lives. I want to take that into consideration because that's part of the opportunity. Like for instance, if you're in a management position, you have a lot more influence on other people than if you're just working. Okay, so that's something that steers you in a direction of yeah, management positions are kind of nice in terms of Great Commission because they give you more influence. That's something that's important. But also making money is also important as long as we're not developing modes of greed or jeopardizing or oppressing people, or because what do you do with your money? Laterno is a great example. He made huge amounts of money. What did he do with that money? He gave up to 90% of it to Laterno. Um, Laterno was one that developed these big caterpillar type and big machinery all over the world. Yeah. And he gave away up to 90% of that book influenced my dad about how he gave away up to 90% of, my dad was a huge giver of money from the farm. And so we didn't use organic methods so much on the farm. I mean, exclusively. We put we didn't use no-till. We put uh, um, fish fertilizer on our strawberries, and we used some. But my dad's purpose was to bless other people with the profit that he'd made, and he'd buy property at a low price and he'd sell it at a high price. He was constantly buying and selling property. And people would come in and they'd buy some of his property and they'd pay him a huge amount. And later they would leave and go off to something else. He'd buy it back at a fraction of the price. And yeah, and we would develop. We spent a lot of time developing property, and we fought the Thousand Friends of Oregon for over to our demise of hundreds of thousands of dollars lost because of an extreme environmental viewpoint that says people shouldn't be developing this. So so we've experienced a very negative side, and we experienced the overregulation of certain things that caused us to have a hard time in farming. Um, so we've experienced a lot of different things, and that's impacted the way I see the environment and the way I see things, and it propelled me.